Hi everyone, welcome back. In today's video, let's look at a concept or technology called containers, right? You might have heard this already. It has been getting a lot of popularity in the recent years, right? Containers. So before going into containers, let's look at a use case which it is trying to solve or the problem it is trying to solve, right? Say you want to start a business, right? You want to start a website or a web application that helps the people to book flight tickets, for example, right? So we know that you need to first have a server or a computer where you can run the application so that users can connect to it and use your application, right? Say got a you got a computer from the cloud or you got a computer from the provider, right? And your computer looks like this, right? So this is your, for example, what is your, it can be called as a book amazing.com. You can change the name if you want. So your flight booking web application and the computer you bought for it is like bookamazing.com, right? So now you expect all the users to come to your website and book their flights super easily with amazing UI and everything. So in order to do that, you need to develop the application. So you create a flights application. So now to make this flights work, what will be your team doing? So your team of developers and other engineers, what they will need, so they will be writing the logic to connect to the external providers, be it United Airlines or American Airlines or Delta or Singapore Airlines, Indigo. So they will be writing logic to get the flights and then display it, and based on which flight your user selects, they should be able to show them the amount, and then you might add a small convenience fee, and then you book the flight from your provider. This can be a external provider, and you hit their computer to get all the details, give it to them, book them, and give them back the receipt. To make this happen, this much logic needs to be written. So the logic you usually write in any programming languages, whichever you write, like, right, whichever your team decides will be good for your application to perform well and look good. So it can be a Angular application and you can have Python. So right, so to have the application running, so the first thing you need is a runtime. So runtime is, you can take it as a software which allows your programming language to run efficiently in your computer. Say the flights has been written using Java, so it will be something like JVM. And even before installing the runtime, what you need in the computer is an operating system. Operating system example is Microsoft Windows, right? But when you are developing something, very usually people install Linux is an operating system in their server because it makes a lot of things easy for the developers. Microsoft is more easy when you use it as a user, right? So even before runtime, you need a operating system. Example, Linux, Windows. Even in Linux, there are different types of distributions or packages available, right? One of it is called Ubuntu. One of the other commonly used distribution is called Red Hat Linux. So based on your team's developers needs, they will decide which operating system will be good for whatever dependencies they use. So what are the other dependencies that are needed for your application? So I'll put it as other dependencies and explain what are there. Dependencies. So it can be port configuration, like network configurations. So if you haven't looked at, or if you are not familiar with how ports work, there is a video on what are ports and you can have a look at it. So you need to define a port on which your application runs, so that whenever some request comes and hit that port, your computer will know that, hey, I need to send it to the flights application because this request is for that application. So you define the ports, and there are other few dependencies if you want to keep it installed and other things, right? So I will not go into deep on the dependencies and even this external provider, right? So you will be giving the application a variable saying, for flights, for Indigo flights, go and contact united.com. So you show United flights here. United is an option and user selects United. You don't store all the United flights on your end. So you go to united.com and fetch all the flights. But you need to say your application that United flights will be available at united.com. So this is one of the dependency which you give to your application, which needs to be configured at the first. So you can take these are the main things that are needed for your application to work. So when you have a computer, you installed some Linux, you installed JVM, and you gave external URL as united.com, right? Now you have an amazing business and you want to develop another thing. So your first application is flights, and it uses Ubuntu, for example, and it uses Java, and so it needs JVM, and URL to get flight information is united.com, for example. So now your business is amazing and you hire a new set of developers, good for them as well. So, and then you now decide to go with the train booking application. Trains. So you now are going to have a train here. So now even if users want to get or book tickets in a train, they still come to you. Amazing, right? So these set of developers think for various reasons that OS needs to be something in the RHEL or Red Hat based, right? And then they want to develop this in Python. So they will be needing a virtual environment. Virtual environment is used to conveniently run Python code, right? And the external URL is not united.com anymore. What are the train providers there? In India, it's irctc.com. Yeah, these guys, this is the government provider for train bookings. In India, I think government handles trains, so every call needs to go to this website, so it's always crowded. So it's very important that you take care of that when you are designing this application. So for that purpose, even the developers have decided or taken decisions based on how we can handle the calls to IRCTC, which details we can store on our how often it needs to go to website, and how often it can just show the information which is present within your application to the user. So these are all under design thinking. So for these various reasons, compared to flights, this is a different use case. So they have decided to go with different set of dependencies, right? So here it is irctc.com. So if you want two different operating systems and two different runtimes, and you want to define different set of configuration ports, etc., port looks something like this: 80 80 for example, or 443, right? So now when you want to deploy or run two things in the same computer, now your developers are confused how they can give the same port to both of it. How can they install two different operating systems in the same computer? So they want to make sure that the runtimes don't clash with their dependencies and packages. So this is where the containers come in. So what containers do is, so instead of going and installing whatever you need in the base computer, you tell me whatever you need, and then I will package them as a package, and then I will run it. So in the computer, instead of having Ubuntu, JVM, VNV, RHEL, so the computer will stay it is, has its own operating system, and on top of it, it will package this and deploy this. So your base computer will not be affected, and then from your base computer, whatever the storage you need, whatever the other configurations you need, so that these two things don't interfere with each other and they run in their own separate packages. Linux supports this, or Microsoft also supports this, but to get those things from your computer or operating system and give to these individual packages, for that there are different types of technologies that are available to make these containers work. One of the very popular providers is called Docker. So the first thing or the only thing you might have to do to make this happen is install a Docker runtime within your computer, and then say to Docker in a language it understands. Of course, there is heavy documentation on that. I want Ubuntu, I want JVM, and I want the port to be 443 and URL to be United for this flights application. And for trains, I want RHEL, VENV, irctc.com, and port 80 and 443. See, it is the same port. Okay, now Docker understands, and it goes and fetches different ports and other variables from the Linux, and it will assign port 443 for flights as well as the train application. But behind the scenes, it will use a different port of the computer. For example, 8001, 8005, assigned to flights and trains. But within this environment, it will still run in 443 or 80. This will also run in 443 or 80. So whenever request from outside comes, it knows the Docker makes sure that, and your Linux helps as well to make sure that 8001 goes to flights and 8005 goes to trains, and in the application you need not change anything. It will still listen on 80 and 443. You can make it as a separate computer, but it is not. So it is having its own operating system, runtime, and everything, but behind the scenes it is running on the same operating system and the same computer. So this is the containers as a whole, the concept, right? So what are the advantages? The first I show is isolation, right? I will remove these arrows. Let's assume your business is amazing and you have a lot of requests coming in, right? isolation. This is explained. So there is no relation between this container and this container, right? They run in their own world, but still they run in the same computer, like, right? So that you don't need to buy new computers or make a lot of adjustments so that they both run peacefully together. They run peacefully in their own world, but for you it is the same computer, right? Second one is scalability. So say your business, as I mentioned, is running amazing and you want to increase the number of requests it can get. Say instead of one user hitting your URL in 1 second, now 10 users are trying to hit you in 1 second. So first user, you will help them book the flight. Second user, you will help them with whatever the request they want, and you will be solving them one by one if you have only one application listening on a particular port, right? Now you want multiple applications to be listening on the same service because 10 users are coming and you want at least 5 users to be, for example, to be handled at the same time. So if you have this kind of setup where you want to install all these things and run the application code again, then you need to make sure that again when a service call comes in, you need to make sure that if you install another part of this, one should go to this and the other needs to go to the second installed application, and again you need to make sure that the sharing of resources and everything happens peacefully. But in containers, all you do is you go and change the container number from, or the number of containers from 1 to 2. So now you do something like this. These both are flights, these both are this packages. You are going and saying that, hey, run 2 instances or 2 number of this containers instead of 1. So everything that needs to be taken care of, networking, configuration, and everything will be taken care by the Docker runtime and your operating system. And then suddenly you have 2 instances running and they don't clash with each other, but they share things whenever they want to share, right? You can mention all these things in a configuration, which things you need to share, which things you can run in your own way, right? So these are all more technical, but as simple as that, you just go and say, hey, run 2 packages of this. You don't have to worry about anything, right? And the third one is portability. Say you decided to go with a new computer from a different cloud provider or a different infrastructure provider, right? So your contract with Lenovo is high or your contract with Google is high and you decided to go with Amazon or Dell, right? So now if you have the basic setup where you go and install all of them manually, you need to wipe them all and then you get a new computer and you go and do everything from the start. You install this, you install this, you install this, you install this, and you set up all these things. In this case, you don't do anything. You just have this configuration already set up, what and all you need, and you go to a new computer, you install this Docker runtime guy and say, hey, I want these things. This and your operating system Linux will take care that it gets all the things, installs it, and runs it again in an isolated environment. As simple as that, you don't have to worry about anything. So these are the main 3 things why containers are super popular. There are a lot of important advantages. Even for developers, or the engineers, it has helped a lot in different things. Yeah, and one another small thing I wanted to tell you is, so we talked about a case where we want 2, right? So what we do when we go to 2 is that we go into your system and say, I want to run this 2. Say tomorrow you need 10, and then you go into the system and then align it to 10, right? Now, even to make this in an easy way, instead of you going and manually starting in another container, you go and click on this configuration and run again, right? So instead of that, even you can orchestrate that, like how, you know, in a orchestra there is a guy or a girl in front who orchestrates the entire music. So you can orchestrate this containers as well. So if say one of your application is not working as expected, so you need to go and delete that, and then you need to run another package of this so that a fresh application starts running and it can serve your user request. So all these things are done by another tool or a concept, and the tool is called Kubernetes. Kubernetes, it's the same word. And the technology behind, or it is called as container orchestration tool. I'm not going to explain that. So there are a lot of amazing engineers who have explained this in the best way possible, but this has made a lot of developers life easily. So if one of these things goes, this will make sure that it comes again. It will also give you a lot of ways to configure, like how many containers you want, how much memory it should use, how much CPU it should use, and you can just say whatever you want and then sit back and relax. It takes care that all your applications are running as expected, right? It can also, for example, it can bring up new containers or bring up new application if it thinks that a lot of requests are coming in, and it can reduce the number of applications running if it thinks that it's a slow time now. So it can save your cost as well, right? It can do a lot of amazing things. Yeah, these are the basic concepts and reasons why we use containers a lot in today's world, especially with the cloud and everything. So yeah, let me know if you have any questions, and let's meet in another video. Thank you. Bye.